Hello guys, we're going to go over the 1.4 lesson. I encourage you to go on to Apex and look at the videos in the 1.4 study portion before coming here. I mainly just kind of want to go over what was taught in those videos and make sure that everything's really clear. Of course, if you have questions after watching this, you can always email me. A reminder, what you have on your screen right now is the note guide that I provided you in class for Unit 1. If you do not have this note guide, or if you need to print a new copy, you can find it on Google Classroom under the Unit 1 note guide. It's about the second to last page there. All right, so the objectives for this section is that we want to be able to construct what we call a 5-number summary, use it to construct a box plot, which is also called a box and whisker plot when we're given a set of data, and then determine if we have outliers. Later on in this section, in the first practice, you'll be shown how to use a graphing calculator to make a box plot. So the first thing, this is actually directly from the first video. You have a set of data, and we need to find the 5-number summary. So the 5-number summary are the numbers that are highlighted here. The first one, of course, is really easy to tell. It's the minimum point, the very first one in an ordered set of data. And then the last one is going to be the maximum point. After that, we usually want to find the median. And we went over how to find the median previously, so let's just go over it again really quick. To find the median, the first thing you need to do is make sure that your data is of course, already in order. This is in order from least to greatest. Then we're going to find the middle part. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data pieces here. So the middle part is between the 6th and 7th data piece, between 11 and 12 here, which gives us that 11.5. After that, we need to find the medians of the first half and of the second half to get the lower quartile and the upper quartile. So looking at the first half of data, which goes all the way, includes the minimum and goes all the way to the median, but doesn't actually include the median itself. We can look at that half of data and find its median. There are 1, 2, 3, 4, 5, 6 pieces of data here. So the median of that piece of data is between the 3rd and 4th data set, and right in the middle of 7 and 8 is exactly 7.5. So the first quartile, or the lower quartile, is 7.5. And then we do the same thing for the upper quartile. We look at just the upper half, not including the median itself. And I find the median of that half, which is right in between 16 and 17. And the number directly in the middle of 16 and 17 is 16.5. So our 5-number summary for this data set is 1, 7.5, 11.5, 16.5, 25. And when you're given a 5-number summary, all you're given is those 5 numbers. Anyone who knows statistics knows when you look at a 5-number summary what those numbers represent. The lower quartile, Q1, and the upper quartile, Q3, are the medians of the upper and lower halves, as I already said. So let's try it again for this one down here. I already have this data in order from least to greatest, 2 to 20. There are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces of data here. I can see my minimum. I can see my maximum. And then to find the median, since there's 16 pieces of data, I'm going to go 8 pieces in. 1, 2, 3, 4, 5, 6, 7, 8. And just double check I have the same number on both sides. 1, 2, 3, 4, 5, 6, 7, 8. So my median is not an actual data point. It could have been just an actual data point. But since my median is between these two numbers, 9 and 9, I pick the number that's between them, which of course is just 9. And then we continue. I find the median of the upper half, or sorry, lower half, I mean. And there's 1, 2, 3, 4, 5, 6, 7, 8 pieces of data in the lower half. So I go 4 in, 1, 2, 3, 4. And make sure I have the same number on both sides, 4 and 4. So my first quartile is between 6 and 6. And so that is 6. It is possible for the median to be an actual number in the data set. This is just what happens when we have even numbers. Okay, last part. Third quartile is going to be in the upper half there. And again, we have 8 pieces of data there. So I want to go 1, 2, 3, 4. Between the 4th and 5th, I have 12.5. So the 5-number summary for this data set is 2, 6, 9, 12.5, 20. Once I have my 5-number summary, I can use that 5-number summary to create a box and whisker plot. The first step to creating a box and whisker plot is to draw a number line underneath where you want your plot to be. On your number line, you need to have numbers labeled from at least to your minimum to your maximum. So I need to make sure I at least have a 2 on here, and then it goes up and up to at least 20. So I'm going to go, let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so my number line's a little longer than I needed it to be, not a big deal. Now, I'm going to draw vertical lines above each part of my number line where I have a piece of my 5-number summary. So the first number in my 5-number summary is 2. So I'm going to draw a vertical line above my number 2. Then my first quartile is 6. So I'm going to draw a vertical line above my number 6. 3, 4, 5, 6. And then my median, 9. And then my third quartile, 12.5. And then my maximum, 20. Now I have a vertical line above each part of my 5-number summary. Now I'm going to draw a box connecting my first quartile to my third quartile with my median in the middle, and then whiskers connecting my box to my minimum and to my maximum. And there I have a box and whisker plot. That's it. In your quiz, they ask you some questions about the shape of our data here. And we talked about shapes of data a little bit before, but we're not going to get into them in depth until the next section. So real quick overview of the shapes of the distributions in a data set of a box plot. I mean, there's 3 basic shapes, and I'll just give you kind of a general idea of what they're going to look like. It's all dependent on the whiskers. So here I'm giving you a general idea of the 3 basic shapes of box plots that we see. On the first one, we can see the whiskers are about the same length. No one is ridiculously longer than the other one. So this is somewhat symmetrical. When a box plot is mostly symmetrical, doesn't have to be perfectly symmetrical, we usually say this is a normal distribution, or that it is mound shaped. Apex says mound shaped a lot. And the reason for that is because when we get into actual curved distributions, you'll literally see a mound, like a perfectly symmetrical little hill there. Okay, the next one, you can see my whisker on the left side is really long. And the reason for that is because most of my data is actually over here between my first and third quartile. And then I have just a few numbers that are way, way, way less over here that's stretching that whisker out really far to the left. So when I have a really long whisker on the left side, we call this left skewed, or skewed left. Likewise, on the bottom one, we have the same situation, but going to the right. The whisker on the right is really long because I have a little bit of data that's way off greater than most of the other data. So when I have a really long whisker on the right, we call this right skewed or skewed right. Moving on. The next I'm going to talk about is the interquartile range, IQR, which I mentioned before when we were looking at variation, but I told you that we weren't really going to calculate it yet. Now we are. So the IQR is always equal to the third quartile of our data set minus the first quartile of our data set. And what it gives us is about how far apart the middle half of the data is. So it's a measure of our variation. So the bigger a IQR is, the more variation in our data, which means our data is more spread out. We also talked before about how when we use the mean as our center, and we like using the mean as our center, we use standard deviation for the variation. When we use the median as our center, we always use IQR, interquartile range, for the variation. And remember, the reason why we would want to use the median instead of the mean sometimes is because the median is resistant to outliers, and the median is resistant to skewed data. When our data is skewed, like these bottom two graphs here, our mean gets stretched towards the ends of those whiskers, but the median is left unchanged. So the mean is a very nice center to use for making predictions, but it's not friendly with skewed data. So when we have skewed data and when we choose to use the median in any case, we're going to pair that with the IQR for its measure of variation. So going back to the data set we were working with before, I could find the IQR for that pretty easily. So again, I'm looking back up here. So the IQR, the measure of variation for this data, would be the third quartile, which was 12.5, minus the first quartile, which was 6. So the IQR for that data set is 6.5, which is representation of how far apart our data points are. Using that IQR, we can also figure out if we have outliers. Outliers we talked about before also. Outliers are numbers that are way, way, way smaller than most of our data or way bigger than most of our data. So you can see in the data set that I have down here that I appear to maybe have some outliers. Most of my data is kind of in this 40 to 80 range. But I have this 2 here that's a lot smaller. And I have this 250 here that's a lot bigger. So I think the 2 and the 250 might be outliers. To test that, we're going to look at the lower and upper boundaries for outliers. In order to find the lower and upper boundaries for outliers, I first need to find my quartiles and my interquartile range. So I'm going to do that. So to find my quartiles, I'm first going to find my median. I have 1, 2, 3, 4, 5, 6, 7, 8 data points here, and they are, well, almost in the correct order. It should say 81, 82. Now it's in least to greatest order. So backing up here, make sure it's in the correct order first. In fact, I'll just rewrite it. 2, 45, 45, 45, 70, 76, 82, oh gosh, I did it again, 81, 82, 250. All right, so the median, again, I have 1, 2, 3, 4, 5, 6, 7, 8 data points. So I go 1, 2, 3, 4 in. Between the 4th and 5th is my median, which would be 73. And then looking at the upper half, the first quartile would be between 45 and 45. So Q1 is equal to 45. And my third quartile will be between 81 and 82, which is 81.5. If I subtract those two from each other, I can get my IQR 81.5 minus 45. 81.5 minus 45 is 36.5. Now I have all the numbers that I need to find my boundaries for my outliers. So looking at my lower boundary first, it's going to be equal to my first quartile minus 1.5 times my inner quartile range. One second. All right, that's negative 9.75. So what that means is that any outliers on the lower half of my data set are going to be less than negative 9.75. And I can see here in my data set that my minimum point is 2. So I don't have any data points that are less than negative 9.75. So there are no outliers on the lower half of this box, of this data set. Now we're going to look at the upper half. So for the upper half, I'm going to take the third quartile, 81.5, and add 1.5 times the IQR. And when I do that, I get 136.25. So that means that any outliers on the upper half of my data set are going to be greater than 136.25. And looking at my upper half of my data set, I do have one number that is greater than 136.25. So 250 is an outlier. So when I draw the box plot for this data set, it's going to look slightly different. I'm still going to have a number line at the bottom that includes my minimum and maximum. So I have to go all the way from 2 to 250. So I'm going to go up by 10, starting at 0. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 50, 200, 250. There we go. Okay, and then just like before, I'm going to draw vertical lines above each of my important points. My minimum was 2. My first quartile is 45. My median was 73. My my third quartile is 81.5. And then for my maximum point, since my maximum is an outlier, if I was doing a standard box plot, I would use 250 as my maximum point and the end of my whisker. Since we're doing a more modern box plot or a modified box plot, I'm only going to include my maximum point, which is not an outlier. So my maximum point, which is not an outlier, is 82. So I'm going to go to 82, which is just a little higher than my third quartile. And I have a very short right whisker. This is definitely left skewed at the moment. But my outlier, 250, for outliers in a modified box plot, we add these little dots. And that's what it looks like. And that's the end of 1.4. So you don't have to do the 1.4 to practice. I got rid of that. But at this point, you should do the 1.4.3 quiz. Let me know if you have questions. And then the next thing after that is a practice assignment in which you'll learn how to make a box plot on your graphing calculator.